Why do polynomial graphs turn based on their degree? Imagine walking along a path that twists and turns in different directions. The way the path bends and flips depends on the shape of the land beneath your feet. In math, polynomial graphs are like that path, and their degree is what shapes their twists and turns. The degree of a polynomial is the highest power of the variable in the expression. It tells us how many times the graph can change direction, which are called turning points or bumps. For example, a polynomial of degree 2, called a quadratic, can have at most one turning point, making a smooth curve like a smile or a frown. A cubic polynomial, which has degree 3, can have up to 2 turning points, giving it a more complex shape with 1 or 2 bends. As the degree increases, the maximum number of turns also increases, but it can never be more than 1 less than the degree itself. These turning points happen where the slope of the graph changes from increasing to decreasing or vice versa. Mathematically, each turning point corresponds to a root of the derivative of the polynomial, which is a new polynomial with degree 1 less. Since the derivative of a degree n polynomial is degree n-1, it can have up to n-1 real roots, which are the potential spots where the original graph turns. For instance, a quadratic's derivative is a linear function, which can have only one root, matching the one possible turning point. A cubic's derivative is quadratic, which can have up to 2 roots, matching the maximum 2 turns. The actual number of turns can be fewer because sometimes the graph flattens out or has an inflection point where the curve changes shape without turning. The degree also influences how the graph behaves at the ends. If the degree is even, both ends of the graph go in the same direction, either both up or both down, depending on the sign of the leading coefficient. If the degree is odd, the ends go in opposite directions, one up and one down. So, in simple terms, the degree of a polynomial controls how many hills and valleys the graph can have and how it behaves at the edges. Understanding this helps us predict the shape of the graph and sketch it more easily. The higher the degree, the more complex and interesting the graph can become, with more turns and twists.